So now let's assume that I'm again going to approach x as x, the value of x as 1, but now from the left side. And from the left side of the number line, we can see that the value of x would be less than 1 now. So let's say if x is 0.9. What would be the value of the function? So f of 0.9 would be what? It would be 0.9 plus 1, that is 1.9. If I bring x more closer to 1, because my ultimate target is to stand at the gate of this number 1 from the left side now. So if I take x as 0.99, the value of f of 0.99 would be what in this function? It would be simply 1.99. If I bring x more close, now if I take x as 0.9999999, let's say 20 times 999. So what would be the corresponding value of this function f at that point? It would be similar. It would be f of 0.999920 times. It would be 1.999920 times. That's it. So just by standing at the gate of this number x is equal to 1, just by standing at the gate, you are so close. You are so close over here somewhere. You are so close, just at the gate. But x is not equal to 1. You are just standing at the gate of this number 1. So just by looking at the previous patterns, if someone asks you that by looking at the previous pattern, what is your judgment that what would be the value of this function when x takes the value as 1? So by looking at the pattern, we can fairly say that by looking at this, we can see that the value of the function looks like that the value of fx at x is equal to 1 would be 2. So without going to the point, either from left side or from right side, we can see that we are getting this feeling while coming very close to this point x is equal to 1, we are getting this feeling that it looks like from the pattern that is coming that the value of f of x at x is equal to 1 is 2. So what it looks like, and just remember that you have to be very close to this point. Very close means that you are just standing at the gate of this number 1. Just after either you are crossing from the right side or from the left side, just after this should be the number 1. It should be the last point, just at the gate of that number. So the feeling that we are getting without going at that point, the feeling that we are getting about the value of the function at that point is the limit of the function at that point. So in this case, we can see that when we are approaching x as 1, either from the left side or from the right side, from both of the sides, we are getting this feeling that the value of this function at x is equal to 1 should be 2. So this feeling is actually the limit of this function at this point, and we write it down in this manner. So in this case, limit x approaching 1 fx is equal to 2. Without doing anything else, this is the first understanding which you have to just keep in your mind always. So this is very important, because the whole story of limit actually begins from this theory. So the first thought that should be there in your mind, that what is the meaning of a limit? So how this is used, what is the implication of this, how we are going to use it. And because when we do something of this sort for the first time, then the first thought that comes to our mind is this, that how we are going to use it. So it is very useful, because this is like the building block of a much bigger building. Let's say many stories, the building which is actually of many stories. So that bigger building is actually the story of calculus. So it starts from here. It's the first building block. So this is the meaning of limit, first of all. Now let's dive one step further. Just listen to this now. So now in this story only that we have just discussed, the interesting name that we have to understand is this now. Can we see that in the case of this function, the case of this example that we have just discussed, we could have approached x from two sides. Either taking x as greater than 1 and then approaching 1, or taking x as less than 1 and then approaching 1. It could be either from the right side and we are approaching 1, or it could be from the left side and we are still approaching 1. So the idea is to actually ultimately approach 1 only, because we have to find limit when x is approaching 1. So when we are approaching x as 1 from the right side, we can see that the value of x is greater than 1. when the value, in that case, the value of x is greater than 1. And we have found that value, we have played the entire game. We don't have to actually do it in this manner. It was just to make you understand. You don't have to actually do, you don't have to fill all these values in this manner. It was just to make you understand. Just keep this thing also in your mind, that you don't have to actually do it in this manner. It was just to make you understand that what is the meaning of a limit. So now when we are approaching 1, in the first case, when we have approached 1 from the right side, we can see that the value of x was greater than 1, because on the right side we can see that the value of x is greater than 1. So the limit that we have found when we are approaching 1 from a value which is greater than 1, that is the right side, that is known as the right hand limit. That is known as the right hand limit. So this is the new name that you have to keep in your mind. Right hand limit. Right hand limit. So this is the first name. When x is approaching 1 from the right side, which is a value, which means the value of x is actually greater than 1. So then we are finding the right hand limit. So in this case, the value of actually representing the right hand limit is in this manner. We'll just write x as 1, x is approaching 1, but from a value which is greater than 1. So hence we'll write 1 plus 1 and simply a superscript, a plus over here. A plus sign in the superscript over here. It's just denoting that we are finding limit from the right side. So fx in this case, the value we have already found that it is 2. So in this case, the value of fx, the value of the right hand limit is actually 2. When we are approaching x from the right side, we can see we could have judged that the value of fx looks like that it should be 2 without going at that point exactly. Similarly, when we are approaching x from the left side, the limit that we are finding is the left hand limit. You just have to keep both these names in your mind, this one and this one. So one is the right hand limit and next is the left hand limit. So left hand limit, as the name actually implies, that we are approaching x as this value 1 from the left side, which means that the value of x is now less than 1. So in this case, the way to represent this is actually x is approaching 1 from minus side. Simply a minus sign as the superscript, and this is the function fx, and we have already discussed that the value seems to be 2. So in this case, the right hand limit which we have found, it was 2, and the left hand limit we have also discussed that it is again equal to 2. So in this case, the left hand limit and the right hand limit, both the values are actually coming out to be the same, and further this is further actually equal to the value of the function at that point, which can be simply found by simply filling the value of x as 1. What is the first thought that actually comes to your mind is this, that what is the difference between these two? Because it looks like, by looking at this first example, it looks like that they would always be the same, but it is not. It wouldn't happen in this manner, and we'll discuss that just after actually discussing this basic logic. You just have to keep your mind ready to actually understand from this moment onwards. So one is the left hand limit, right, and next is the right hand limit. Now